I just wanted you to see.
In this lecture, we'll be discussing about another classic problem of synchronization, which is known as the dining philosopher's problem. So first of all, we'll be trying to understand what is this dining philosopher's problem, and then we'll be seeing if we can solve this using semaphores. All right, so first let's see what is this dining philosopher's problem. So in this dining philosopher.
So a semaphore is a construct in an operating system. It's a method in an operating system that's used for the purpose of synchronization. And so when you're looking at processes that go sideways, this dining philosopher's problem is an analogy. So it's not a literal thing. I mean, you can consider that each of the philosophers are separate processes, and what's laid on the table are operating system resources, right? And so the narrator of this YouTube explains all of this, but it's a classical method of explaining this long-standing challenge for operating systems, how they can resolve synchronization so that you have better concurrency, right? It's worth watching more than once, I'll say that. And there are some other related challenges with the controls that are used to synchronize processes efficiently. So that's what we investigate in our first chapter, and then in chapter 6, and then in chapter 7, we take a hard look at what happens when processes are, deadlock. What does deadlock mean? How do we avoid deadlock? What are the consequences for deadlock, and so on. So you're going to hear quite a bit about the classical problems that present with process synchronization. And one of the first that we'll review is called the critical section problem. So there are software and hardware solutions. So let's get started. Processes can execute concurrently, and some of them cooperatively. So not all processes are what would be considered cooperative processes. Cooperative means we intend for the processes to interact with each other. When an operating system is multitasking, you can have interests that don't play nice with each other, and they still execute concurrently, but that doesn't mean they were designed intentionally to be interactive. I hope that distinction makes sense before. Concurrent access to shared data may result in data inconsistency. So if you have shared data between processes, corruption is a possibility. Maintaining data consistency requires mechanisms to ensure orderly execution of cooperating processes. What we're saying is it has to be intentional, right? You have to design this to work together. Suppose you want to provide a solution to the consumer producer problem that fills all the buffers. We can do so by having an integer counter that keeps track of the number of full buffers. It says initially counter is set to 0. It is incremented by the producer after it produces a new buffer, and is decremented by the consumer after it consumes a buffer. In any case, what we're looking at here is the counter increment. And because we're incrementing upward the counter, this is a statement for the producer, obviously. And then here's the counter decrement. So if you're presented with two coding examples where we ask about a producer-consumer scenario and an issue with the counter, we might ask you, which is this? And you're going to look and see the plus plus here and go, oh, all right, it's increasing. It would have to be a producer. It's decreasing. It would have to be a consumer. You have other processes that get in the mix, and what happens is that essentially more than one process starts to interact with the same segment of code, and that creates instabilities. So there are cases commonly where more than one process is interacting with the one segment of code, and that leads to corruption because they're both working changes to the variables and data that are being written to and read from, and that's commonly referred to as the critical section problem. So if you want to avoid a critical section problem, what you want is a case where each segment of code is only ever engaged and changed and updated by one process at a time. Does that make sense?
Yeah, that makes sense.
Okay. Some of the slides are summarizing quite a bit of explanation, and I'm not sure that short statements are very clear. I think it may help if we have a chance to glance over the study guide before we pick up the rest of this on Thursday. What I'd like to do is stop here and end our session early so that you have time to work on the reconciliation for the Module 2 assessment, and that you have a chance to review and complete the final attempt of the Module 1 assessment. So, are there any questions before we stop today?
No questions.
All right.